Hello everyone. In this video, I'm going to discuss the concept called thread priorities. So what is this thread priorities in the sense? Generally, we will be setting the priority. So to specify that in which order, so it has to get executed. Okay. So here also in this Java threads concept, so we are going to define, we are going to schedule which threads need to be get executed first in this operating system. Okay. So just Java thread priorities will be in the range of so 1, 5 and then 10. Okay, so which will be specifying the minimum priority called, which is with the set with a constant of 1, and maximum priority with a constant of 10, and this normal priority with the constant of 5. So that means we are having an option to set the priorities like normal priority, minimum priority, and then maximum priority. See, threads with high priority are more important to a program. So, which we are allocating the processor time before lower priority threads. That means, so we are going to specify that we are trying to run that threads which is having the more priority before the slower priority threads. Okay. That means here we are trying to guarantee that particular threads will be going to execute first here. Okay, so for that one we are going to create a thread by implementing a runnable interface. So this concept we have already discussed about this runnable interface in the earlier videos. Okay, so while defining this one, we need to follow three like so how we are going to set this priorities in the sense, either we can set with the normal priority, which will be stating with the value called 5, and minimum priority and then maximum priority. So for that one, so if you observe this example, it will be extending the thread class and it is going to specify the run method. Okay, so here we are having this print statements called running thread name. Here we are trying to get the name of the thread, and then we are going to get the priority of the thread. Okay, so we are expecting the name of the thread along with the priority also. Okay, so in my main method, I'm going to define those two priority classes called multi-priority one for this M1. Okay, where I'll be creating this new test multi-priority one. Okay, and for this M1, I'm trying to set the priority called minimum priority. And for this object called Jntuh, I'm just trying to set the priority called maximum priority here. And if I try to run that thread m1.start and m2.start, so if we try to execute this program, here we'll be getting the thread running thread name is 0, and for that particular thread the priority is 10. Okay, and then after finishing this thread, it will be moving to the next thread, that is running thread name is thread 1. Okay, so where the running thread priority is 1 over here. Okay, so one is with the maximum priority and second one is the minimum priority. See, one thing we need to observe in the sense, whatever the thing we have specified with the maximum priority, that will be executed first, and whatever the thread we have specified with the minimum priority, so that will be executed next over here. So that is with the thread priorities. Next, coming with synchronization threads. So usually this synchronization is the capability to control the access of multiple threads. Okay, so and also which is going to be shared with the any resources. Okay, so we can say that synchronization in Java is nothing but the capability to control the access of multiple threads that is going to share among the resources. So in this multi-threading concept or this multiple threads, so these here the multiple threads try to access the shared resources at a time to produce inconsistent results, right? So that is why this synchronization is necessary for reliable communication between the threads. So that is why we are making use of this synchronization in the threads. Why? Because in the multi-threading concept, it will be making access of shared resources at a time. Okay, so to produce this inconsistent results, so it will be making use of multiple threads will be trying to access the shared resources. So that's the reason we will be making use of this synchronization for that reliable communication among the threads. See, the synchronization is mainly used to prevent thread interference, and then to provide or else to prevent the consistency problem. Okay, so this thread synchronization are of two types. One is with the mutual exclusion, and second one is the inter-thread communication. So what is this mutual exclusion in the sense? So this is a type of property of process synchronization. So which is going to state that no two processes can exist in a critical section at any given point of time. Okay, so we are stating that no two processes can exist in that particular critical section at any given point of time. Here, the term first, which is figuring out in this mutual exclusion is any process synchronization technique, so which is being used, so must satisfy the property of mutual exclusion. Okay, so without which it would not be possible to get rid of the race condition. Okay, so we are saying that no two processes can exist in the critical section at any given point of time. So under this, we are going to specify this mutual exclusion in three ways. One is with the synchronized method and synchronized block and static synchronization. So what is the synchronized method in the sense? So which is used to lock an object for any shared resource. See, when a thread is going to invoke a synchronization method in the sense, it will automatically acquire the lock for that particular object and it is going to release it. Okay, so whenever the thread completes its task, it is going to release that object. Okay, so synchronization method is used to lock an object for any shared resource. Next one is synchronized block. So this is a piece of code that can be used to perform synchronization on any specific resource of a method. Okay, so this can be used to perform synchronization on any specific resource of the method. Here, the synchronized block is used to lock an object, okay, for any shared resource, and the scope of this synchronized block is smaller than the synchronized method. Okay, here, so this locking an object for any shared resource and the scope of that synchronized block is smaller than the synchronized method. Next one is static synchronization. So this static synchronized method is also a method of synchronizing a method in Java. So which is nothing but no two threads can act simultaneously static upon the synchronized method. Okay, so the only difference is by using the static synchronized is we are going to attain a class level lock such that only one thread will operate on the method. Okay, so this is a method of synchronizing a method in Java. So which is nothing but no two threads can act simultaneously static. And that is upon the synchronized method. Okay, so next one is cooperation, that means inter-thread communication. So it is a type of mechanism in which a thread is passed running in its critical situation and it will be giving a chance for another thread, or else it is allowing another thread to enter into that same critical situation to be executed. Okay, see, if one of the thread is executing and it is in a critical situation or else critical section in the sense, here it is going to stop that critical section and then it is allowing the another thread to enter into that critical section which is to get executed. Okay, so these are the two representations of the synchronization threads, that is with the mutual exclusion, and second one is the cooperation or else inter-thread communication in Java. So this is an example which is specifying that synchronization threads. Here I'm just specifying a class called table and void print table. This is a method which is not synchronized. Okay, and here I'm going to specify the loop for I is equal to 1, I less than equal to 5, and I increment, and I'm just trying to print n star I. Okay, in the try, I'm just making the thread to wait for 400 milliseconds and then an exception. So it is a general exception E. Okay, and then I'm just printing that exception. And here I'm going to create a main class called my threads, which is going to extend the thread class. And here I'm going to create a table. Okay, that means I'm going to create a object for this table, and then I'm just calling that this dot t. Okay, and specifying the public void run. And here I'm just trying to print the table for 5 times. That means here I have represented the loop, no? So that 5 times print has to be get printed. And again, I'm going to define another class called my thread2, which will be extending the same thread class. And again, I'm going to run this object. So that's why I have specified this. So this is a keyword which is used to run the current object. Okay, that's why I'm going to, oh, I'm using this keyword. And then again, I'm just representing that t dot print table 100. Okay, next, so likewise, I'm going to repeat this my thread classes for multiple times. Okay, so for the main class, here I'm going to represent that object is equal to new table. Here I'm going to create only one object. Okay, but here I'm just specifying my thread. For my thread 1, I'm specifying object t1, and for my thread 2, t2. Here I'm starting that threads t1 dot start and t2 dot start. Whenever it will be starting its execution, it will be going to this my thread 2 and this my thread 1. So where it is going to print the print table over here. Okay, so as it is going to get repeated, it will be starting from this. That means it is going to print 100. No, so in the same way, it is going to repeat it for 5 times, and it is going to print that elements over here. See, after this t1 dot start and t2 dot start only, it is going to run this code. Okay, so where it will be repeating this for 5 times. Okay, so this is how it is executing the code. Next one is inter-thread communication. So as I told you that inter-thread communication is nothing but a mechanism. So which is going to pass the running thread in the critical section, and it is allowing the other thread to enter into that critical section. Okay, so for that one, we are having the three simple methods which can makes this thread communication possible. That is public void wait, public void notify, and public void notify all. So these methods have been implemented as final methods in Java. Okay, see, whenever we are going to specify this final keyword in the sense, so method overriding is not possible in this final keyword. Okay, so here these all will be available in all the classes. All the three methods can be only for this within a synchronized context only. Okay, so what does this public void wait meant for in this sense? So this will be causing the current thread to wait until another thread is going to invoke the notified. Okay, until that it will be in the waiting state only. Next, public void notify. So this will be waking up the single thread, so that is waiting on its objects monitor. Okay, next, public void notify all. It is going to notify only single thread, no, whereas notify all will be waking up all the threads that called wait on the same object. So it is for a single thread and it is for the all the threads. So here, this is the example which is specifying the inter-thread communication. Okay, see, this is a simple specification like it has been specified with the int amount is equal to 10,000, and then so I'm just declaring a variable along with its value, and it's a type over here, and synchronized void withdraw method. Okay, and here I'm just trying to print a statement called going to withdraw. As this is a withdraw method, I'm just trying to execute, that means print that statement. And here I'm just specifying a condition that if this dot amount is less than amount, okay, then it has to specify less balance. Okay, and here I'm just trying to represent the try and catch for exceptions. And also again I'm representing this dot amount is equal to amount. Okay, that means withdraw completed. And here I'm going to represent deposit, so where it will be specifying going to deposit. Okay, if see generally if we will be depositing the amount, in the sense the amount will be credited, no? So here this dot amount plus is equal to amount where deposit is completed. After finishing this one, it needs to run with a method called notify. Why? Because it needs to notify a single method thread over here that has been deposited or not. Okay, next we are going to specify a main method where we are going to create an object. Okay, and for this one I just don't want to edit this or else modify this method, so that's why I have represented final. And here I'm going to create a new thread, so which will be defining with the public void run. So this is the run method, and here I'm just stating the thread start method. Okay, and again a new run method, one is for withdrawal and another thread is for deposit. Here I'm going to specify two threads, one is for the withdraw and another one is the deposit. Okay, for both the two methods I'm going to specify run and start methods. Okay, see if I try to execute this program, first of all it will be executing this statement like going to withdraw. So after that it will be entering into that statement. Okay, so here withdraw amount, in the sense it will be representing like so initially the amount is 10,000, right? Now it will be entering, it will be printing the statement like going to withdraw. Okay, so so withdraw amount is here, it has been represented like 15,000, no? So as it is 15,000, it will be representing like less balance waiting for deposit. See 15,000 amount is less, greater than 10,000. That means this dot amount is less than amount. Initial amount is 10,000. See how we can draw 15,000? It is not possible, no? So that's why it will be printing the statement like less balance waiting for deposit. And next we have to deposit. For that one, here we will be running this method called c dot deposit 10,000. So where it is going to deposit, and whatever the previous amount we are having, for this 10,000 we will be additionally adding how much amount? Again 10,000 to that amount. Okay, so after doing that one, it will be executing the statement like deposit got completed. Okay, afterwards then we can able to withdraw 15,000 from the account. Okay, so this is how, see this, the simple thing I just want to say is, first of all, this thread withdraw is running over here. Okay, in that critical situation, it has passed that withdraw thread and it has allowed the deposit thread to run. Okay, after finishing that deposit thread, again the withdrawal has been executed. So this is what the inter-thread communication is going to do the process. So it is passing the current thread in the critical section, and then it is allowing the next thread to execute, and after execution of that particular thread, it is going to resume the process of this remaining of this previous thread. So this is how inter-thread communication will be happening. Okay, so this is what with the example of this inter-thread communication and its methods. Okay, thank you.